You know, as a committed educator who is determined to maintain a high standard, we all are aware of the GMAT 41's consistency to see that our students get the best academically, especially for those who have chosen the path of science, since majorly this platform is dedicated to these ones. But I am a kind of sad. Yeah, I am sad. Not in any other way of life anyway. I'm sad with respect to what is happening to our system of education. And before I start this wonderful class today, I really want to say this. And it seems like those who are supposed to care and do the right thing regarding our system of education, they are not doing anything regarding it. And so today, I sadly want to say that it is a shame, a total shame, yes, that a whole authority for that matter, will just because of one person wake up, boom, curriculum change without proper planning. Yes, no proper planning. No proper planning. You see, I've just been thinking since yesterday when I came across the news, although I think the news has been flying for some days now. And what just kept running through my mind is the answer I get from some students who claim to be science students. And then I ask them, what is your best subject? What is your best subject? And you hear somebody who says he's a science student or she's a science student tell you that my best subject is civic education. Something is going north, right? Or you hear someone who says, I'm a science student, tell you my best subject is CRS. I don't like chemistry. Oh, I hate physics. See, maths? No. I don't want to have anything to do with maths. That is what someone who says is a science student is claiming. And then you hear the person telling you my best subject is home management. Oh my God. Well, this is so sad. It's hurting me because, like I said, I think somehow, somewhere, we are living what the right thing should be, and we are doing what is irrelevant. At the end, I feel pity for parents. Yeah, most generally. I feel pity for parents most generally because most times their children, yeah, the younger ones, they bear the brunt of all these things, not knowing their academic path, their career path, because of this so many subjects and sometimes irrelevant that students are being choked with as against core subjects. If we say that we are going for something, we should understand. And yeah, the world is changing. A lot of things are happening. We want to bring some things into the education system. I think there are right ways of doing it. So honestly, like I said, it's a shame. Some people are doing the best they can. Others who are really supposed to lead and pattern, I don't know, like I said, using the authority otherwise. But may God help us. Parent, wise up. You know the best for your child. If your child has chosen the career path, please make further inquiry. It's not all about someone from somewhere just announcing something and saying whatever. Please. In the field of science, like we know, core subjects there include physics, chemistry, maths. Now you talk biology if you're going medically, okay? Then of course English is a kind of universal language somehow because it's lingua franca. In Nigeria, it happens to be one of our major language, if not our first language as it stands now. Any other subjects are just added. And I think it's more than important we understand that we should give enough attention to this key science subject. Let our younger ones know about this. Before a science student will tell you, I hate chemistry, I hate math, I hate physics. My best subject is civic education. Then you're wondering, what are you doing in science? Anyway, I hope those who have ears would hear. May God help us. You are welcome to the GMAETS 41's live class. In our chemistry class today, like I told you, I'll be coming on live every 8 p.m. on Monday, on Wednesday, and on Fridays. Today we are looking at valence electrons in chemistry. When we talk about valence electron, this is just one part picked from atomic structure. Today, on the GMAETS 41's platform, I will be exposing something that students should know, something significant that educators should also know, because it has become so bad, yes, so bad, that this foundational aspect of chemistry has been neglected, by some educators, by many students who are not even aware of what they are supposed to know. And for that reason, you hear students complain of chemistry. And then I say, chemistry is a very interesting and simple subject. So from atomic structure, we'll be picking just this part, valence electron. And then we'll see how the knowledge of valence electron is going to help us, in further aspects of chemistry. So I want to start by asking, what do you understand by the term valence electron? Have you heard about that before? By the way, do you know how to draw atomic structure? Because that is where everything about this comes from. And that is where the weight of chemistry as a science subject hangs. Because atomic structure is something you don't joke with. Let us define valence electron. Are you ready? With your writing material? Valence electron. Perhaps I'll write a definition on the board, but let me just define those that can write. You can follow up as I dictate, after which I'll write a definition on the board. Valence electron is simply defined as the electrons that occupy the outermost shell of an atom. The electrons that occupy the outermost shell of what? An atom. These are the electrons found in the outermost shell of an atom. That is what we refer to as valence electron. Valence electron, okay, let's say electron or electrons, as the case might be, is or are. Is in the case of one, are in the case of more than one, is or are. The electron or electrons in the outermost shell, of an atom. So if you draw the atomic structure of an atom, how many electrons are found in the outermost shell? That number of electrons is what we refer to as the valence electron. Interestingly, getting to know the valence electron of an atom is very simple. And like I said, from basic aspect of chemistry, of course, here in Nigeria, those in grade 10, from SS1, as we call it, senior secondary school 1, they are the ones that are exposed to this topic. Yes, that is a class from which the concept of valence electron is introduced. If you're not going to SS2, that is grade 11, grade 12, You know, we don't talk about, oh, valence electron as a way of defining them or defining it. Rather, we apply the knowledge of valence electron to handle other higher aspects of chemistry. Sadly, at the first level, which is SS1, sometimes some educators do not emphasize on the importance of this valence electron. In fact, sometimes when some of us come to the concept of atomic structure, you know, we passively teach it as if, okay, there is nothing in it. Oh, this is an atom, this is a structure. An atom has proton, electrons, and neutrons. Okay, draw atomic structure. Talk about electronic configuration, and then that's all. Oh, the first 20 elements. Please, the GMAETS 41 is stating in clear terms that we should not handle this aspect of chemistry in this manner. If we had been doing it before, please let us quit. This topic is not a topic that should be taught passively. Over many years of experience, I've come to find out that the weight of chemistry, at least if not for anything at O level, hangs on this aspect: atomic structure, and then the things in it, which of course one of them is valence electrons. I am going to be taking this lesson gradually in parts as I expose the things, the many things in chemistry that valence electrons gives you information about. We have defined what valence electrons is or are. Before we move on into talking about what I would refer to as the application or importance of the knowledge of valence electrons, I would like, and we'll now talk about the valence electron. Let us look at the atomic structure of sodium and then the atomic structure of oxygen. Okay? Yes, I have a reason why I picked both of them. Or perhaps the atomic structure of chlorine. Or should I make it 4 atoms? We're going to draw that of 4 atoms. 1, let us look at the atomic structure of oxygen, atomic structure of sodium, atomic structure of aluminium, atomic structure of chlorine. So let us see. Atomic structures of oxygen. I mentioned sodium, Na. I mentioned aluminium, Al. And of course, I mentioned chlorine, Cl. So here we have that of oxygen. Oxygen is atomic number 8. So the first shell, which is the K shell, is going to contain 2 electrons. We are looking for 8 electrons. Oxygen, atomic number Z is equal to 8. Oh no. Please make sure you follow through with this class. Do not joke with it. Like I said, sometimes we play with this topic. And that is why many students, I won't say some, remember I am in the field of teaching. I will meet many of them. Good enough as God would have it. I teach those at basic level, those at secondary school level, senior secondary, and I have the opportunity of also coaching and teaching those in advanced level. You hear many people tell you that they don't like chemistry. Okay? All right, let us move on. So, we are talking about the atomic structure of oxygen. So, O here, Z is equal to 8. This Z means atomic number. In our last chemistry class, I talked about that, you know. So we are going to draw an atomic structure with 8 electrons. The first shell, K, we carry a maximum of 2. The second shell, L, we can carry a maximum of 8. But here we are trying to distribute 8 electrons because this is atomic number 8. 2. All right, have been introduced already. So here we have 6 left. So we have 1, 2, 3, 4. You know, you distribute them around like this. We are left with 6 electrons, you know, to make altogether 8, since we have 2 here already. Now, if you count the number of electrons we have here, these are 6. So we need 2 to make it up to 8. And the 2 can still enter the second shell, L, because the second shell can contain a maximum of 8. So I will pair this and I'll pair this. This is the atomic structure of oxygen. Now from this atomic structure of oxygen, clearly the valence electron, the number of electrons in the outermost shell, because the outermost shell here is L, the number of electrons is what? 6. Which means that the valence electron of oxygen is what? 6. Please, dear students, take note of something. I am not hosting this class just to tell you what valence electron is. No. That is too simple for me to just come and be talking about valence electron. You know the definition perhaps even before this class. My aim is to open your eyes to things you may not really have thought about. Maybe you've done this topic before, but you didn't give attention to this part. Remember, I told you for the 2025-2026 academic session, once GMAETS 41 steps out, to teach you friends, there are key points I'll be exposing and emphasizing, because these are foundations, these are key aspects that holds that particular subject here in a way. So you want to give attention to them. You don't need to joke with them. You don't need to forget them when you learn them. And of course, for that to happen, there is a way, a standard, a pattern that the knowledge needs to be put out so that students can appreciate, and of course, speak and breathe science. Let's move on. The electronic configuration of this atom, electronic configuration is 2, 6. I've taught the concept of electronic configuration already on this channel. You have a video lesson on that. Electronic configuration is the number of electrons in each shell. So in the K shell, we have 2, look at it, and then in the L shell, we have 6. Now from here, what will be the valence electron? The valence electron is 6, which is the last number here in the electronic configuration. So you see, from electronic configuration, one can get valence electron. From atomic structure, one can get valence electron. And these things, you can resolve them. You can analyze them using the network of your brain. You mustn't draw them out. If I say atomic number 8, which is that you know that the first shell will carry 2. You are looking for 8. Therefore, you are left with 6. The second shell will now carry the 6. Because why the K shell carries a maximum of 2, L, M, N, O, P, Q shells, which correspond to what we call principal quantum number, small letter n, equal to 2, 3, 4, 5, 6, 7. They carry a maximum of 8 electrons. Now let us look at the atomic structure of sodium. Sodium is atomic number 11. The atomic structure of sodium goes this way. The first shell, which is K shell, carries a maximum of 2. So out of 11, 2 is gone. We are left with how many? 9. Out of that 9, 8 can enter this L shell. So you distribute 8 round, come back and start pairing. Okay, so we have 8 on this shell L. The total number of electrons now is 10. And we are looking for 11 electrons because this is atomic number 11. We have to draw another shell because the second shell is complete already. Fix another shell. And then the remaining 1 electron to make it 11, you fix it here. This is shell N. Now, what is the electronic configuration of sodium? As you can see, it is 2, 8, 1. What is the valence electron of sodium? Valence electron of sodium is 1, which is the number of electrons in the outermost shell. I have a reason why I'm doing this, because don't worry, let us be done drawing the atomic structures. Next, aluminium. Aluminium is atomic number 13. So it will have 13 electrons. Let's be fast with the atomic structure. Already it is believed you should know how to draw atomic structure by now. Okay, so we have this. We've gotten 10. So it's left with 3. The 3 will now be distributed to shell N. This is K shell, L shell, and then N. What is the electronic configuration of aluminium? Electronic configuration is 2, 8, 3. And what is the valence electron? The number of electrons in the outermost shell is 3. Finally, let us look at chlorine. Chlorine is atomic number 17. Please, let me check that this has not cut off from your view. Rahul Pradhan, you are welcome to join the class. I like only love chemistry, Nityam. That's good. It's good that you love chemistry, okay? It's good you love chemistry. All right, so that of chlorine showed, so I would proceed to draw it. Chlorine is atomic number 17. The first shell, as usual, we carry a maximum of 2 electrons. The second shell here will carry all the 8, you know, because we are looking for 17 electrons. Now the third shell, already we have 10 electrons in the first 2 shells. So we have to introduce the third shell, M, so as to get the remaining 7 electrons. So 1, 2, 3, 4, 5, 6, and 7. So we have 2, 8, 7 as the electronic configuration of chlorine. Electronic configuration is 2, 8, 7. And then the valence electron is 7. Number of electrons in the outermost shell. Now, I've drawn these atoms, the atomic structure. Okay? I want to ask you these questions now, so that from here we can now start appreciating this concept of valence electron when dealing with atomic structure. Remember, like I said, if this video, right, if this particular lesson, let us assume that an educator comes across it, a teacher comes across this topic, assuming you are a science teacher who takes chemistry, please, GMAETS 41 is using this opportunity to appeal to you, to beg you, be a source of academic knowledge of chemistry to our younger ones. Never you teach atomic structure passively, please. As a matter of fact, if not this issue of scheme of work being drawn sometimes, yeah, scheme of work is very good, but sometimes, you know, key points that needs to be emphasized are not being highlighted. I know this is the area that teachers now have to come in fine, okay? But let the content also show a high level of commitment, so that teachers would also, okay, learn from it, especially in cases where we find it difficult to train and retrain our teachers. But then, as a teacher, as an educator, please always try to improve yourself. It's for your own good. Look at me as GMAETS 41 now, yeah, with total humility, because I always give the credit to our God and Helper Jehovah. But the truth is that at every point in time, I try to upgrade my knowledge in what I teach. I try to train and retrain myself. Why? Telling myself I want to give the best and be the best at what I teach. So when you have that mindset, it's not about you bragging, no, but you want to impact life. When you deliver that lecture, that lesson, let somebody at home say, yes, I have learned this topic like 1 + 1. That will be to your own advantage as a teacher. So like I said, if you're a teacher and you come across this video, please, I am appealing to you, take my appeal to heart. If you're teaching atomic structure, do not teach it passively. As a matter of fact, I drew out a curriculum content, right? Yeah. I drew out a curriculum on this aspect of chemistry, atomic structure, and I had to come up with about 6 parts on atomic structure, so as to ensure that from basic level of introducing chemistry, students will appreciate and love chemistry. Not a science student ending up to tell us, I hate chemistry, my best subject is CROS. My best subject is civic education, is home management, is home economics. Follow with GMAETS 41 and you'll see the 6 parts as I deliver the lectures gradually. This class is going to focus on part 1, where we are now going to apply the knowledge of valence electron to identifying metals and non-metals. Identifying metals, non-metals, as well as identifying the group that an atom belongs in the periodic table. Which means that from this level of learning, like I said, because this particular topic actually targets scholars, students in grade 10. In Nigeria here, our SS1 students. So that from that level, you are now expanding their knowledge. By the time they move on to, let's say, grade 11, and you come to periodic table, because it's on that periodic table that we learn the concepts of groups and periods. When you are talking about groups, they understand what you're saying. When you're talking about the period of an element, because they have good knowledge of atomic structure, they understand what you're saying. But by the time you handle this topic passively, without bringing out necessary details, I am not saying details, but necessary one, because these details are really so necessary. If you follow up with the GMAETS 41 classes, like I said, by the time I would have covered and delivered these parts, of course, it's going to take a while. Since we have 6 parts or so, it will take roughly 3 weeks, 4 to 5 weeks. Yes, because I'm not going to rush it. I won't. Whenever you join the class, be patient, because I'm doing this for your good. Be patient as I expound this to you. How do you use the knowledge of valence electron to know if an element is a metal or non-metal? At least for beginners, we usually focus on, metals of the S block. All right, metals of the S block. Okay, if I say S block, somehow those in SS1 may not really be able to grab it. So let me just calm down. Metals in group 1 and group 2. Metals that are found among the first 20 elements. Because at least before someone steps grade 10, the person is supposed to have known the first 20 elements. Because in grade 9, yeah, that is being taught very well in integrated science. Okay, so let us use the knowledge of valence electron to identify which ones here are metal, or which one is a metal, and which one is a non-metal. Now pay attention, this is where you might now have to write well, but let me see if I can use this part of the board. Okay, I hope it does not cut off. I hope this part does not cut off anyway. So how do you identify metals? So here I'm going to write identification of metals. Identification of metals, or identifying metals. Identifying metals from valence electrons. From valence electrons. Identifying metals from valence electrons. Now, how do you know that this element is a metal? From the knowledge of valence electron, it is very simple. Any element whose valence electron is, are you ready? Any element whose valence electron is, should I now move on? Let's go. 1 or 2 or 3. Generally, that element is considered a metal. So you see how the knowledge of valence electron has exposed this to us. If the valence of electron of a metal, if the valence electron of an element, I take that again. If the valence electron of an element is either 1 or 2 or 3, that element is a metal. If valence electron, VE, I'll be using VE in the notes. If valence electron of an atom is 1 or 2 or 3, that element is a metal. That element is a metal. Good. So that's the first thing you want to take note of. Please let me check that this did not cut off from your view. Oh no, it cut off. So I'm going to adjust the camera. I'm going to adjust the camera. Please be patient. Okay, so here we go. Please make sure you share this link to your friend. The link to this class, share it to your friends. If you have academic WhatsApp group where maybe your classmates or your departmental group mates, they are there, share the link to that group. Encourage them to come to GMAT 41 and learn. If you are yet to subscribe to this channel, what is holding you back? You see that wonderful knowledge is actually running out, to you from this class, from GMAT 41. Encourage them to join. You that is taking this lesson right away, if you have not subscribed, right away click on the subscription icon. And after you subscribe, move on and click on the notification bell. If you click on the notification bell, select all, so that anytime I come on live or I upload any content, you will be personally notified. YouTube will quickly notify you that something is on at GMAT 41 for you to learn. Okay? And you can support us more. You can send us super thanks, super chats,